Hello, my name is Hari Bastola. I'll be presenting a demo video on gravitation for BYJU'S teaching specialist. So when we say or when we hear about gravitation or when we deal with gravitation, we'll be basically dealing with mass objects. That means those objects that contains mass has to do something with gravitation, and if there is any object which doesn't have any mass, like for example we say the mass of electron is almost negligible or zero, in that case those type of objects has nothing to do with gravitation. Okay, so when we say gravitation or gravitational force, what it means is two mass objects attract each other. That is the thing. Okay, that means there is a force of attraction between two mass objects. Now if there is force of attraction between two mass objects, I am also a mass object, things present around me are also mass object, this marker is also a mass object, the phone I am recording with is also a mass object, right? But I don't see this marker being attracted towards the phone or a textbook attracted towards the table, right? We don't see that in our life. Two human beings, they are pulling each other without anything, right? Because mass object attraction, force of attraction means they must come together or they must move towards each other. Okay, so where is gravitation actually present, or what is the significance of gravitation in our day-to-day life? Where do we actually observe gravitation? Now you see one thing, if I have to keep this marker here, I need to hold it up or I need to tie it up with a rope fixed there, up there, right? Unless then I cannot do that. But have you ever imagined or have you ever wondered this planet of the size of Earth or even bigger planets or moon, they are hanging in the space and they are not tied with anything, right? They are going round and round around the sun every year. Okay, they do not lose their track, they go in the same path. Okay, so what is the thing that is keeping the planet fixed in the space or other objects like other planets or moon fixed in the space? It is the gravitation, or it is the gravitational force of attraction between the sun and planets that keeps the planet fixed in space, right? So you see, high tides and low tides in ocean are caused because of gravitational pull of moon and earth. That is another example of gravitation. That means gravitation is very much a real thing we see in our day-to-day life, right? So without gravitation our survival won't be possible again on earth. That is how important gravitation is. Okay, now let us go here. You may not see two objects, mass object moving together, but there is still a force of gravitation between them, right? That force is very small for smaller objects. That is why we don't see them coming together. Okay, so there is force of attraction for all mass objects, but that force of attraction is visible or significant for those objects with very large mass, like the planet Earth or sun or moon. Okay, now if I have two objects, I'll give you the method to calculate the force between two objects. If I have two mass objects separated by a distance r, then the force of gravitational force of attraction between them is given by G m1 m2 divided by r square. Right, G is known as universal gravitational constant. Its value is 6.67 into 10 to the power minus 11. Right, this is a constant which is applicable throughout the universe. Okay, even if I have to go to moon or other planets, value of G will remain same. It is a universal constant. Okay, now m1 and m2, that means gravitational force between two objects. This is the quantitative method to calculate, or this is the method, or this is the formula to calculate the force. Okay, so it depends on the product of masses of two objects, and it depends on the distance between the two objects, right? So now you must remember one thing, that the gravitational force of attraction between two mass objects depends not only on individual mass, but it depends on product of masses of two two objects interacting. Okay, that means if I have to calculate the gravitational force between Earth and Moon, then it depends on the product of mass of Sun, I mean Earth and Moon. If I have to calculate the gravitational force between Earth and Sun, then the force depends on the product of mass of Sun and Earth. Okay, so I'll explain you in detail now. If I have a small object of mass smaller m, let us say, and I have a large object of mass capital M, right? So let us take the example of this marker and surface of the Earth or Earth. Now, which one do you think will experience more force? It may appear to you that this being a larger object will apply more force on this, right? But that is not the case. You see the formula, force depends on product of masses, right? So both the object will experience equal force in magnitude. Magnitude wise force will be equal. Okay, direction wise they will be opposite, right? Whatever force this object is experiencing, this object also will experience the same force. That means if I release this pen from my hand, it will go downward, right? But I don't observe, or you don't observe planet Earth coming upward, right? That means this is also a mass object, planet Earth is also a mass object. So planet Earth also experience the same force which this marker is experiencing, but we don't see planet Earth moving upward. What is the reason? The reason is this: the force experienced by this planet Earth is too small compared to its mass, right? It's very big in size, very big in mass, so the force is very small, so it doesn't move. But for this marker, the force is sufficiently large to create motion of this marker, right? So gravitation, you must remember, whenever we deal with gravitation, we are dealing with mass objects only. Those objects that do not have mass cannot be put or cannot have gravitational pull. Okay, thank you so much.